Another application of systems with two equations are mixture type problems. And in this one, we've got caramel corn at $2.50 a pound being mixed with some peanuts that are more expensive at $7.50 a pound. And we want to get a 20-pound mix that will be able to sell for $3 per pound, okay, without losing any money. So we want to know how much of each should be used. Well, the two types of things that I'm mixing are caramel corn and peanuts, and I want to know how many pounds specifically of caramel corn, so I'm going to call that C, how many pounds of the peanuts, so I'm going to call that P. What I know is that I have a total weight, right? They told me a total of 20 pounds, so C plus P, the weight, the pounds of the corn, the pounds of the peanuts, needs to equal 20. Now what about my cost? Well, it's $2.50 per pound for the caramel corn. So the value of that caramel corn is $2.50 times however many pounds I have, which is C. So my cost or value here is 250C. And we're adding peanuts that are $7.50 per pound. So I'm going to take the 750 times P. And that needs to give me the cost of my final product. And it's not 3, it's 3 times 20 because there's 20 pounds that are each valued at $3 per pound. So that second equation, if you want to go ahead and multiply through to get rid of the decimal, would be 25C plus 75P equals 600. You could easily solve by addition elimination or substitution, either one, and you should end up with 2 pounds of peanuts and 18 pounds of caramel corn. We have a lot more caramel corn than peanuts, and that should kind of make sense to us because our new price for this mix is only $3 a pound, which is just slightly more than the caramel corn. We'd be losing money if we had a lot more peanuts in there.